When it arrives closest to the sun, the Earth would be on the opposite side, and we won't be able to observe it. But that's exactly the time when it could do a maneuver to slow down and visit us. And one wonders whether this trajectory was designed by some extraterrestrial intelligence.
A line has been crossed, a secret unveiled, hinting at a future for Mars that few could have ever imagined. The world is on the cusp of understanding an unparalleled cosmic event, all thanks to an alleged NASA leak that points to the James Webb Space Telescope and its unprecedented observational power. Coupled with the mind-bending abilities of quantum artificial intelligence, this leak reveals an absolute certainty. The asteroid 3I Atlas will strike Mars. The precision of this prediction is what truly stuns experts, and the shocking impact date is something you won't want to miss. Prepare for a deep dive into how our most advanced technology uncovered this dramatic celestial timetable. The unveiling of 3I Atlas. Many people are crazy about space news, but not all things are what they seem, and this leak pulls back the curtain on a level of predictive power previously thought impossible. For years, scientists have worked tirelessly to track near-Earth objects and other celestial bodies that could pose a threat. Their methods, while advanced, have always had limitations, especially when dealing with objects far off in the darkness of space. Enter the JWST, a technological marvel orbiting about 1 million miles from Earth. This telescope doesn't just see invisible light like its predecessor, Hubble. It observes in infrared, allowing it to peer through cosmic dust and gas clouds, detecting objects that would otherwise remain hidden. It's like having X-ray vision for the universe, able to spot the faint heat signatures of distant asteroids. The sheer scale of its mirror, nearly 21 feet across, gives it a light-gathering capability that is absolutely unprecedented. Imagine collecting light that has traveled for billions of years. That's the kind of power we are talking about. But the James Webb Space Telescope, as incredible as it is only one piece of this puzzle. The true wow factor here, the thing nobody tells you, is the integration of this raw, complex, astronomical data with something even more cutting-edge: quantum artificial intelligence. Traditional computers, even supercomputers, process information in bits, which are either a 0 or a 1. Quantum computers, on the other hand, use qubits, which can be 0, 1, or both at the same time, thanks to a mind-bending concept called superposition. This allows them to perform calculations at speeds and complexities that classical computers can only dream of. For a task like simulating the trajectories of countless celestial bodies, factoring in gravitational pulls, and predicting future positions with extreme accuracy, quantum AI is a game changer. It can explore millions of possibilities simultaneously, far beyond what any conventional system can manage. The alleged leak suggests that JWST's highly sensitive infrared data on 3I Atlas was fed into a specially developed quantum AI algorithm. This wasn't just about spotting the asteroid. It was about refining its orbital path, accounting for even the most subtle gravitational nudges from other planets. Asteroid 3I Atlas, itself a mystery until recently, measures roughly 1/2 mile in diameter. While not a planet killer, an object of this size hitting Mars would undoubtedly carve out a massive crater, potentially hundreds of miles across, and unleash energy equivalent to many thousands of megatons of TNT. The most shocking fact is the alleged precision of the impact date. Previously, asteroid predictions often came with wide margins of error, sometimes years or even decades. This new report, however, speaks of a date that is remarkably specific, almost to the hour. This level of accuracy, if true, showcases the incredible leap in predictive capabilities that the combination of JWST and quantum AI offers. It transforms asteroid tracking from a game of probabilities into a near certainty. And you can see this everywhere in the hushed conversations among those in the know. The implications are truly profound. This isn't just about Mars, it's about what this technology means for Earth's own long-term safety from cosmic impacts. The universe just got a whole lot smaller, and our ability to understand it and perhaps protect ourselves just got exponentially bigger. The precise mechanics of this quantum leap in planetary defense reveal a hidden layer of technological prowess, something few outside a select few could comprehend. But what exactly is 3I Atlas, and why has its trajectory suddenly become such a critical focus for this advanced technological duo? The deep space detective work. The red planet Mars has long captivated humanity's imagination. It's our closest planetary neighbor, a world of rust-colored deserts, polar ice caps, and ancient riverbeds that hint at a wetter past. But what many overlooked is the constant silent ballet of celestial objects in our solar system, a dance where colossal rocks can and do occasionally collide. The alleged leak regarding 3I Atlas dramatically highlights this ever-present cosmic reality. This isn't just about a new impact, it's about an interstellar object, a type of wanderer from beyond our solar system, making an unexpected and precise appointment with Mars. Asteroid 3I Atlas, according to the unconfirmed reports, isn't just any space rock. The 3I designation suggests it's an interstellar object, similar to Oumuamua or Borisov, which briefly visited our solar system in recent years. This origin immediately adds another layer of complexity and fascination. These objects travel across vast stretches of interstellar space, often at incredible speeds, and their trajectories are difficult to predict even for brief visits, let alone a precise impact. Imagine trying to predict the path of a bullet fired from a moving train and then trying to account for every tiny air current along its journey. That's a simplified version of the challenge. The thing nobody tells you is that tracking such objects from light years away and then predicting their behavior once they enter our system is a monumental task, one that tests the very limits of classical physics and computational power. The James Webb Space Telescope's role in this, you see, is absolutely crucial. Its infrared instruments are sensitive enough to detect the faint heat signature of an object like 3I Atlas, even when it's far from the sun and not reflecting much light. This ability to see in the infrared allows the JWST to pick up on objects that would be invisible to optical telescopes in the cold, dark emptiness of deep space. Furthermore, by observing the slight changes in its heat signature over time, the JWST can gather data about the asteroid's size and rotation. These details, to put it mildly, are vital for accurate trajectory calculations. Even a slight wobble or an uneven distribution of mass can subtly alter an object's path over millions of miles. Now imagine taking this incredibly detailed, but still vast, data set and feeding it into a quantum AI. This is where the truly mind-bending power comes into play. Classical supercomputers can simulate possible trajectories one after another, trying to narrow down the most likely path. A quantum AI, leveraging the principles of quantum mechanics, can explore all possible trajectories simultaneously. This parallel processing capability allows it to factor in thousands or even millions of variables at once. Not just gravitational tugs from major planets like Jupiter and Saturn, but also the more subtle influences of smaller moons. This dramatically reduces the noise in the data, leading to a much clearer and more precise orbital prediction. It's like having a cosmic GPS that accounts for every bump and turn in the road ahead, not just the major highways. The precision of this quantum calculation is what truly makes this alleged leak so significant. Instead of a general time frame, we are reportedly looking at a specific day and potentially even hour. This isn't just an advancement, it's a paradigm shift in our ability to anticipate celestial events. It hints at a future where planetary defense isn't just reactive, but truly proactive, with ample warning for potential mitigation efforts should they ever be needed for Earth. For Mars, a world without a protective global magnetic field, an impact from an object 1/2 mile wide would be a truly violent event. The sheer force would gouge out a crater potentially 50 miles wide and several miles deep. This deep space detective work by the JWST and quantum AI is revealing the stark realities of our cosmic neighborhood. What then are the broader implications for the human dream of making Mars our second home, and how might this alleged impact reshape our understanding of planetary survival? A Martian scar on our cosmic ambition. The prospect of an asteroid, even one as small as 3I Atlas, at roughly 1/2 mile across, impacting Mars carries a weight of profound significance, both scientifically and for humanity's grand ambition to become a multi-planetary species. What many overlooked is that Mars, unlike Earth, has a very thin atmosphere, roughly 100 times thinner than ours. This means that incoming objects don't burn up as easily, and impacts are a much more common and destructive phenomenon. This alleged confirmation by JWST and quantum AI isn't just about observing a distant event, it's about witnessing in exquisite detail the raw power of the universe at play and what it could mean for our future. This isn't a minor fender bender in space. A strike of this magnitude would blast a crater potentially dozens of miles across and several miles deep. This event, even if observed from Earth, provides a stark reminder of the fragile nature of planetary bodies and the constant threat of cosmic collisions. It also brings into sharp focus the urgent need for advanced planetary defense systems, not just for Earth, but for any world we hope to inhabit. While no immediate action can be taken to stop 3I Atlas from hitting Mars, the advanced warning provided by the JWST and quantum AI could give scientists an unprecedented opportunity to study the lead-up to the impact and the aftermath. This real-time observation of a planetary impact event would, to put it mildly, be invaluable for understanding the dynamics of such collisions. Many people are crazy about finding extraterrestrial life, and Mars is a prime candidate for past microbial life. You see, this isn't just a story of doom, it's also a story of unparalleled scientific opportunity. The ability to predict such an event with such accuracy, thanks to the combined might of JWST and quantum AI, fundamentally changes the grand chessboard of space exploration. It moves us from merely reacting to cosmic events to truly anticipating them, opening new avenues for research, and ultimately for safeguarding our future in the cosmos. But not all things are what they seem, and the path to understanding such complex predictions is never straightforward. Could this event, even if confirmed, reveal hidden truths about how we interpret cosmic data and what unexpected challenges might still await us? The alleged NASA leak detailing the 3I Atlas impact on Mars has certainly generated immense wow factor and captured the imagination of many. The idea of JWST and quantum AI working together to pinpoint such a momentous event sounds like something out of a science fiction blockbuster. But not all things are what they seem, and the thing nobody tells you is that even with the most advanced technology, the universe still holds countless mysteries and variables that can influence outcomes, or at least our understanding of them. This is where a down-to-earth perspective becomes crucial, especially for those of us watching from afar, wondering if all this happens overnight. Will humanity use this power for good, or will secrets like this always remain hidden in plain sight? Don't miss more unbelievable space stories. Like this video and subscribe for more mind-blowing revelations.